Let's look at a couple of more examples where we can solve these trig equations using our factoring methods. Here I have negative 2 sine squared x is equal to 3 sine x plus 1. If you remember back when we solved quadratic equations in previous classes, the way that I solved this type of an equation was to gather all of my terms up onto one side and then see if I could factor it. So I have 0 is equal to positive 2 sine squared x plus 3 sine x plus 1. And since I have a squared term, a regular term, and a constant, I can try to factor this. So I'm going to break it up into its two sets of parentheses. The first term would break up into 2 sine x and sine x. I know I have, this sign tells me I have two addition signs, so I have a plus and a plus. And I'm looking for the factors of 1 that add to give me 3. Well, there are only one set of factors for 1, and that has to be a 1 and a 1. So let's just check that we have this factored correctly and can get back this middle term. Negative 2 sine x times 1 plus 1 sine x, so negative 2 plus 1 is 3. So I have it factored correctly. Now I take each of these factors and set them equal to 0 and solve each of these two equations. So I have 2 sine x plus 1 equals 0, followed by just sine x plus 1 equals 0, and I'm going to solve each of these two equations. I'll just start over here on the left. I'm going to subtract 1 to the right-hand side, and I get 2 sine x is negative 1. Divide both sides by 2, and I find out that sine x is equal to negative 1/2. So for what values, when I take the sine of it, do I get negative 1/2? I have to be talking about being in quadrants 3 and 4 to get a negative sign value. So that for what angles in quadrant 3 and 4, when I take the sine of them, do I get negative 1/2? That's going to be at 7 pi over 6, when x is 7 pi over 6, because that's in quadrant 3, along with 11 pi over 6. So these are the two solutions for this first equation. We're not finished yet because I have another one to do. So this one's going to solve by subtracting 1 to both sides. And now that I have it down to this, let's see. Again, I'm looking for angles that are, when I take the sine of them, I get a negative value. So I'm talking about being in quadrants 3 and 4. So when I take the sine of some angle, I get negative 1, and that occurs at pi. So we'll just write it down here with the rest of them. So I have 3 angles in this case, which are the solutions for this equation. Now, let's look at another one together. This one is kind of tricky. This one says the cosine of x times the cotangent of x is equal to negative cosine x. Let me show you the right way to do this, and then I'll show you what happens if you fall for the trick here. Okay, so when I solve this, I'm actually going to gather all of my terms up, all of my cosine terms up on the same side. So we're going to add cosine to both sides. So I have cosine x, cotangent x, plus cosine x is equal to 0 now. I have a cosine x in both of these terms, which means I can factor cosine x out, leaving me with cotangent of x plus 1 equals 0. And we will set each of the factors equal to 0 now. So cosine x is equal to 0, as well as cotangent x plus 1 equals 0. So for cosine x to be equal to 0, I have to be looking in quadrants 1 and 4. For the cosine to be 0, I have to be looking in quadrants 1 and 4, and that's going to give me x values that are pi over 2 and 3 pi over 2. Now for this portion of the equation, cotangent x is negative 1. So for cotangent to be negative, I would be looking in quadrants 2 and 4. And the angles, when I take the cotangent of them that give me a negative 1, are at 3 pi over 4 and 7 pi over 4. So these two as well as these two angles, all four of those angles are the solution to this equation. Now let me stop for just a second and point out a very common mistake in this particular equation. So I'm going to rework this equation. I'm going to rewrite it over here. If I have cosine x, cotangent x is negative cosine x. How many of you, and be honest with yourself, would have divided both sides by cosine of x? So if I divide by cosine, that gets rid of this cosine x over here, but it leaves me with cotangent of x is equal to negative 1. And when I solve this, I find out that x would be equal to 3 pi and 7 pi over 4. The problem with that is I only ended up with 2 of the angles out of the 4 that were possible solutions. So by dividing off my trig function, I lost 2 of the angles. So the moral of that story is, do not divide your trig terms, because you end up losing solutions. One more. Let's look at one more together as far as factoring is concerned. So we have this equation here. It says we're going to see if we can factor this. Okay, so I know that this is going to break up, or I think it's going to break up into 3 sine x times sine x, because that's the only way this first term will break up. This is a negative sign, which means I have to have a positive and a negative sign here. And 2. So I'm looking for the factors of 2 that subtract to give me negative 1. The factors of 2 that subtract to give me a negative 1. So I'm going to put 2 here and a 1 here. So let's check. That gives me negative 3 plus 2, which is a negative 1. So I factored this correctly. Now let's set each of these two terms, or each of these two terms equal to 0 and solve. So 3 sine x plus 2 equals 0, as well as sine x minus 1 equals 0. So the left-hand equation looks like 3 sine x is negative 2. Therefore, sine x is negative 2/3. And for over here, I have sine x is equal to positive 1. I can do sine x is equal to positive 1 because I know what that value is off of the calculator. Off of the unit circle. When I take the sine of some angle and I get back a positive 1, I know that I am looking at x at pi over 2. Okay? The problem comes in with this over here. Sine of some angle is equal to negative 2/3. This is not a common angle that I know of off of my unit circle, so we have to do this on the calculator. So on the calculator, we're going to find out what the inverse sine is. Remember, we are looking at x being on the interval between 0 and 2 pi. So we're in radians, and we want to make sure we have that on the calculator. And we're going to take the inverse sine of negative 2/3 and see what is returned. So when I let the calculator take the inverse sine of negative 2/3, it returns for me negative 0.73. We'll call it negative 0.73. Let's talk about what happened when we took that. What did the calculator just return for us? Remember that inverse sine lives in quadrants 1 and 4. And when I take the inverse sine on my calculator, it returned for me a value down here. This value was negative 0.7297, right? We found that x was equal to negative 0.73 from the calculator. But the solutions that I want to give need to be positive. And when I take the inverse, my solutions for this for the equation are supposed to be in quadrants 3 and 4, right? Because when I take the sine of some angle, I get negative 2/3. So I have to be talking about angles in 3 and 4, quadrants 3 and 4. So how do I adjust my solution the calculator gave me to account for that? Well, if I have this angle here where I just dropped down a negative 0.73, then I know that I also have, because my angles are symmetric, I also have that value over here. And I can find this angle, that positive angle, in quadrant 3, I can find that by taking this 0.73 angle measurement, so 0.73, adding that to pi, because halfway around is pi, plus that little 0.73 gives me that whole angle that I want. And then for the fourth quadrant angle, I could find that by taking several different options, but what if I said 2 pi minus 0.73, or 2 pi plus we'll just call it minus 0.73. And that's going to give me the two angle values I need. When I put that in the calculator and I say 0.73 plus pi, you should have the value 3.87. And when I say 2 pi minus 0.73, you get the angle 5.56 plus pi over 2, and there is your solution to this particular equation. Just remember, when we let the calculator give us a solution, we have to keep in mind what that solution means.